Hey everybody, welcome back to Mr. Aparicio's geometry course. Today's video lesson is going over section 1.6 of geometry, which is all about angle pairs. Let's get into it. We have 4 angle pairs to learn about today, starting with complementary angles, which are just 2 or more angles that have a sum of 90 degrees. So any 2 angles that add up to 90 degrees. For example, if you have a 20-degree angle and a 70-degree angle, those are complementary because 20 plus 70 equals 90 degrees. In our first example here, we're asked to find the complement of a 41-degree angle. A complement of any angle would just be a number that adds with it to equal 90 degrees. So we're trying to figure out what number, which we can call x, when added to 41 equals 90. And that just gives us a little equation there that we can solve. We can subtract 41 from both sides here to determine that this angle would have to be 49 degrees. A lot of our angle pairs will include adjacent angles. Complementary angles are no exception. Adjacent complementary angles would be 2 or more angles that have a sum of 90 degrees that share a side and a vertex together. So if we took those 2 numbers I showed you earlier, the 20 and 70 degrees, if we made those adjacent to each other, so if I had an angle like so, that was 20 degrees, and then next to it, sharing that side there in the middle had a 70-degree angle, those would be adjacent complementary angles because they're sharing that side there in the middle. Notice that those will combine to give us a right angle, 90 degrees. This example here is assessing your ability to recognize complementary angles with that right angle that's there. I know it might be a little blurry here. There's a 22 degrees here, a 4x here, and we have a right angle at the vertex of both of these angles. So that's adjacent complementary angles. Therefore, they have to add up to 90 degrees. So that 4x plus the 22 have to combine to give us 90 degrees. That's also a little throwback to our angle addition postulate. Little angle plus little angle equals big angle. Our algebra here would require us to subtract 22 from both sides. We end up with 4x equals, this would be 68, and then we would divide both sides by 4. That would give us x equals 17 in this problem. These word problems are really where our knowledge is put to the test. We have angles A and B that are complementary to each other. So that first sentence alone tells me that these angles have to add up to 90 degrees because they're complementary. So I could even start with a little shell here for my equation. Angle A plus angle B, we know equals 90 because they're complementary angles. We're told angle A is 8k minus 1, angle B is 13k plus 7. We have to solve for angle B. Well, just like we would do with the segment addition postulate or angle addition postulate, I can substitute these values into this equation that I've written here. So instead of writing angle A again, I can write that expression for A, which was 8k minus 1. Carry down my plus sign. Instead of writing angle B again, I can write that expression of 13k plus 7. And we know that it has to add up to 90. And then we can do algebra from there to solve for k. So combining like terms, I have 8k and 13k on the same side of the equal sign. I combine them with the signs that they have. That's 21k's. I have this -1 and +7, also like terms on the same side of the equal sign, so I'm using the signs that they have. -1 plus 7 gets me to plus 6. 2 more steps from here. I gotta subtract 6 from both sides to get that 21k alone. So I'm subtracting by 6, that gives me 21k equals 84. And I can divide both sides by 21 to solve for k, which is gonna be 4 units, right? Now, we're gonna be good students. This question is not asking us just to solve for k, it's asking us to solve for the measure of angle B. So a habit for good students is always rereading and making sure that we're answering the question that's asked. So our k needs to get plugged into that 13k plus 7 for angle B. I'm gonna write that over here just so that I can keep everything on screen. So I know angle B is 13k plus 7, so I'm just plugging in my value for k, my 4 there. 13 times 4 would give us 52. 52 plus 7 would give us the measure of angle B being 59 degrees. I really like this next example here. We got a lot of critical thinking involved in this. We're told that 2 angles are complementary to each other. Again, right away, this tells us that these angles have to add up to 90 degrees. We don't have a name for these angles, so that we can just name them ourselves. I can call them angles A and B. So I know from the jump that angle A plus angle B has to equal 90 degrees. Then we're given this little hint about our angles, that one is 14 more than the other, and then we're asked to find the value of each of these angles. So what we're going to need to do here is come up with expressions for angle A and B, and this hint is going to help us along our way. I'm going to start with angle A. There's one angle in this little hint here that we know nothing about, and that's the other. That other angle, we know nothing about it, so we're going to assign it a variable. It's completely unknown. I'm going to call it x. Now for angle B, we do know something about it. We know that it's 14 more than this. So it's 14 more than x. Well, how do we write that, 14 more than x? Well, that would just be x plus 14. 14 more than x. Now with these expressions, I can substitute those into a plus b equals 90, and I can actually solve for the x that I've created here. So I'm going to do that over here. So angle A, x, plus angle B, which is x plus 14, equals 90. And again, hopefully you caught that. I'm just substituting these terms into the equation. And then we're doing algebra, combining like terms here. X plus x is 2x's. I can now get that 2x alone by subtracting 14 from both sides. So that gives me 2x equals 76. Then I can divide both sides by 2 to get x equals 38. All right, now knowing that x is 38, I can find the value of each angle by plugging my x in here to angle A and angle B. Angle A is just x, so it's just 38 degrees for angle A. Angle B is x plus 14, so we have 38 plus 14, that gives us to 52 degrees for angle B. Our next angle pair is supplementary angles. That's two or more angles with a sum of 180 degrees. So if I have an acute angle that's 70 degrees, an obtuse angle that's 110 degrees, those would be supplementary because 70 plus 110 equals 180 degrees. Our first example is nice and easy here. It's just asking us to find the supplement of 122 degrees. The supplement of an angle would just be an angle that adds with it to equal 180 degrees, like supplementary angles do. So we're trying to figure out what value, which we can call x, when added to 122 gives us 180. And that's a solvable equation here for this. So we subtract 122 from both sides, and we would find that that angle is 58 degrees. We have another one of these word problems where we're given a little hint about angles here. We have two angles that are supplementary. Again, right away that tells us we have two angles that add up to 180 degrees. Again, I can call those angles A and B if I'd like to. I'm actually gonna write this over here again so I can fit everything on screen. So I got angle A plus angle B equaling 180 because they are supplementary angles. Now I have to come up with expressions for A and B, which I get from this hint. One angle is 23 less than the other. Remember, the other is completely unknown. I can just give that a variable like x. So I'll just say that that's angle A. I'll just call it x. Our angle B, though, we know that detail. It's 23 less than this. So how do we write an expression that's 23 less than x? Well, that would just be x minus 23. 23 less than x. Now I can take those values and plug them into this equation. So angle A, which is x, plus angle B, which is x minus 23, equals 180. And that's solvable now for us to figure out what x is. X plus x combines to give us two x's. I can then move that 23 to the other side of the equal sign by adding 23 to both sides. That'll give me 2x equals 203, and I can divide both sides by 2 to get x equals 101.5. And again, I can now take my x and plug it in to find the value of each supplementary angle here. So angle A was just x, so that's just 101.5 degrees. Angle B was x minus 23. So I can plug in my 101.5, subtract it by 23, and that would give me 78.5 degrees for angle B. In our next example, we're told that angles C and D are, again, supplementary. So we know from the jump that angle C plus angle D have to add up to 180 degrees. We're given expressions for C and D that we're just going to plug into this equation. So angle C we know is 10x plus 13 plus angle D, which we know is 7x plus 14, equals 180 degrees. So again, all we've done is we've taken these values and plugged them in our equation here for C and D. Now we're doing algebra to solve for x. I have like terms to combine. I have 10x and 7x on the same side of the equal sign. That combines to give me 17x's. I got plus 13 and plus 14 on the same side of the equal sign. That combines to give me plus 27. I can get that 17x alone now by moving to 27. Since I'm crossing the equal sign, I would need the opposite function here of subtracting by 27. So that gives me 17x equals 153. Now I can divide both sides by 17 to get my value for x, which should be 9. I'm gonna double check that really quick. 153 divided by 17 is 9. And now I can plug that x in to answer my question because it's asking me to find the measure of angle D. So I need to plug that into this 7x plus 14, which I'm gonna do right here. 7 times our x, which is 9, plus 14. 7 times 9, 63. 63 plus 14 tells us that the measure of angle D is 77 degrees. Our next angle pair is the linear pair. Linear pairs are just adjacent supplementary angles. Adjacent supplementary angles. So remember, adjacent means next to. They're going to be sharing a side and sharing a vertex, and they're going to be supplementary to each other, adding up to 180 degrees. The key thing here is remembering what 180 degrees looks like. Hopefully go back to 1.5 and remember that that is a straight angle. So linear pairs have to have straight angles involved, which means there needs to be something straight, like a segment or a line. In this case over here, I'm going to draw a line. Now, if I just add one ray going off one side of this line, it's going to create a linear pair. So we can see here, I have these angles right here, 1 and 2. Those angles share this vertex right here, and they share this side. So that's adjacent angles on one side of a straight line, making them adjacent and supplementary. That's what a linear pair is. The key here is the visual. Students will often forget throughout the year what a linear pair looks like, right? It looks something like this in our next example. The key in this example is identifying the linear pair. We have this segment AC with one segment branching off of it, and that's creating two angles here. They both share the vertex B. Those angles both share side BD. Let me give you the visuals here in case you're struggling with that. Here's angle ABD. Here's angle CBD. They both have side BD. Their vertex is both B. So this is adjacent angles that are forming a straight angle together. This is exactly what a linear pair looks like. So we identify the linear pair. We remember our definition says that these are supplementary to each other. So that means these angles have to add up to 180 degrees. So angle addition now. Little angle plus little angle equals big angle. So that little angle, that's 7Q minus 46, plus this little angle, the 3Q plus 6, equals that large straight angle, which again, we remember these are supplementary. They have to add up to 180 degrees for that straight angle there. Then we can do our algebra to solve for Q. Again, combining like terms, 7Q and 3Q on the same side of the equal sign gives me 10Qs. Negative 46 and plus 6 combine to give me negative 40. Remember, when we're on the same side, we use the signs that we have. So that's negative 46 plus 6, giving me that negative 40. Still have that 180 on the right. Adding 40 to both sides gives our 10Q, or helps us get our 10Q alone there on the left. So we end up with 10Q equals 220. And we can divide both sides by 10 to solve for Q, which would be 22 units. Again, we're going to make sure that we're good students in answering our questions. This doesn't say solve for Q, it says solve for the measure of angle ABD, so we need to plug that Q in here to angle ABD. Remember, if you're ever struggling to find an angle, you can always trace the letters from A to B to D. That gives us this opening where the 7Q minus 46 is. So angle ABD equals 7 times Q, which we found out was 22, minus 46. 7 times 22 is 154. And when we subtract 154 by 46, we end up with 108 degrees for the measure of angle ABD. Here comes my favorite kind of word problem again with our hints here. We're told two angles form a linear pair. So again, right away, we know something about the value of these angles. If they're a linear pair, that means they're supplementary, which means they have to add up to 180 degrees. So if I call these angles A and B, I know right away that angle A plus angle B has to add up to equal 180. Now our hint here has a little extra flavor to it. One is 10 more than twice the size of the other. Well, let's first remember that the other is unknown. I can just call it X. So let's say that's angle A, I can just call it X. Angle B, though, is 10 more than twice the size of the other. So let's first start with the twice the size. If I need something that's twice the size of A, or twice the size of X here, then I just multiply it by 2. So that would be 2 X's. And then the 10 more part would just be adding 10 to it. So 10 more than twice the size of X would be 2X plus 10. Those values now are just going to plug right into this equation and we'll be able to solve for X. So angle A, which is X, plus angle B, which is 2X plus 10, equals 180 degrees. Got like terms here of X and 2X. That combines to give me 3 X's. Still at the plus 10. Still got the 180 over here. I can subtract 10 from both sides to give us that 3x alone on the left equal to 170. And we're going to get not a pretty number here. As we divide both sides by 3, we're going to end up getting x equals 56.6 recurring, which is fine. We can get ugly decimals, we can get negatives for variables as long as what we plug them into ends up making sense in the end. So we're trying to find the measure of each angle in this pair. Well, we already know that angle A is just X. So that means angle A would be just 56.6 recurring. And for angle B, I can just take that value now and plug it into that 2x plus 10. So angle B equals 2 times our x, which we know is 56.6 recurring, plus 10. And the way that we can calculate this is going back to here, when we do 170 divided by 3 in our calculators, we get that 56.6 recurring already on our screen, just filled out a whole bunch of 6's. We can take that now and multiply it by 2, which will give us 113.3 recurring, and then just add 10 to it from there, which will give us 123.3 recurring for the measure of angle B. I'd say it's rare that we get these kind of decimals with these problems, but it can happen. Got to be prepared for that. Decimals and negatives can happen for your variables. We have an important little note here. Students are often confusing linear pairs and supplementary angles with each other. So let me make sure that this is understood. Supplementary angles are any two angles that add up to 180 degrees. They don't have to be close to each other at all. They don't have to be adjacent. So I can have a 100-degree angle right here and an 80-degree angle over here. Those are supplementary because they add up to 180. Linear pairs have to be side by side. They have to share a side. So linear pairs will always look something like this, like a straight line with one segment branching off of it, right? Those are still supplementary, but they're specifically called a linear pair because they're sharing that side and they're off of that straight line. Where supplementary angles can be detached. They don't have to be side by side. The key thing here, the most important thing, is that you recognize that off of a straight line needs to be 180 degrees. So that means this straight segment I've drawn here, if I were to draw 4 segments off of this, all the little angles that are created still need to add up to 180 because they're all on one side of our straight line. So in this case, that would be 1, 2, 3, 4, 5 little angles that all give me a sum of 180 degrees. The last angle pair that we're going over today is vertical angles. These are angles that are opposite of each other at the intersection of lines. So So anytime we have segments, rays, or lines intersecting each other, they're gonna give us vertical angles. So let's see what that looks like. I'm gonna draw a line. Remember, lines have arrows on both sides. Draw another line. And we'll notice that that creates 4 angles here, which I'm gonna number in this problem. There's 1, 2, 3, and 4. 4 angles at the intersection of these lines. Angles that are opposite of each other would be like 1 and 3. They're across the intersection from each other. 2 and 4 are also opposite angles, so those are vertical angles. 1 and 3 are vertical, 4 and 2 are vertical angles. And a very important note here that I forgot to put, that you need to know and have memorized, is that vertical angles are congruent to each other. So because angles 1 and 3 over here are vertical, we would know that angle 1 is congruent to angle 3. So if angle 1 was 100 degrees, angle 3 would also have to be 100 degrees. Again, angles 4 and 2 are also vertical angles. They have to be congruent. Angle 4 is congruent to angle 2. So if I knew angle 4 was 80 degrees, then angle 2 would also be 80 degrees. I know you probably can't see on the video here, but this is a 105 and a 2x minus 11 in this example. And this is really assessing our ability to identify that those are vertical angles. Because I have 2 lines intersecting, these angles are opposite of each other or across each other. Those are vertical angles, which have to be congruent to each other. And remember, these congruent things, congruent means equal in measure, we just set them equal to each other. So that 2x minus 11 must be equal to the vertical angle, which is 105 degrees. And we can do algebra from there to solve for x. I can get that 2x alone by adding 11 to both sides. That'll give me 2x equals 116. I can divide both sides by 2 then to figure out that x would be 58 degrees in this example. In our next example, we're solving for multiple variables and we're combining some of these angle pairs that we've been learning about. I think the first thing that you should look for in any complex figures is vertical angles. I think that they're the easiest to spot. In this case, we have a 76 given to us here. Hopefully you can identify that this y is vertical to it. It's across the intersection. So y and 76 are vertical angles. That means that y must also be 76 degrees because vertical angles are congruent to each other. From here, we need to identify linear pairs. Remember that linear pairs are going to look like this. 2 angles side by side off of a straight line. And that occurs right here. It also occurs in a few different places, but this will help us here to solve for x. Those are a linear pair, side by side on a straight line. Remember, 180 degrees on the straight line, so those two have to add up to 180 degrees. So x plus 76 equals 180. If I subtract 76 from both sides, I can determine that x is 104 degrees. From there, I can find another vertical pair. We have x and z as vertical angles. They're opposite each other across at this intersection. They have to be congruent, just like y and 76 were. So since x is 104, z must also be 104 degrees. Our next example is very similar, just the complex algebra here makes it a little bit more challenging for us to solve. But again, hopefully you can identify the vertical angles here. This 3x minus 33 and that 2x plus 5 are opposite of each other at the intersection. Those are vertical angles. And remember, angles that are vertical, we set equal to each other. All right, I'm gonna do this here so I can try to fit all my work for this problem on screen. That 2x plus 5 must be equal to my 3x minus 33, because again, vertical angles are equal in measure, they're congruent. Now I can do algebra here to solve for x. I'm gonna move my 2x to the right. I always like moving my smallest x's, so I'm gonna subtract 2x from both sides. That leaves me the 5 on the left. 3x minus 2x leaves me with just an x. Still have that minus 33. I can get the x alone now by adding 33 to both sides. That gives me x equals 38. Okay. Now from here, it's very important to catch on what we're doing here. With this 38, all I can do with this value is plug it into where the x's are to determine the measures of these angles. It doesn't matter which one I plug it into, but I have to plug it into one of them. I'm just gonna pick this 2x plus 5, and I'm gonna plug that 38 in for the x there. So 2 times x, which I know is 38, plus 5. 2 times 38 is 76. 76 plus 5 gives me 81 degrees. So make sure you're with me here. I know this angle is 81 degrees, which means this angle is vertical to it should also be 81 degrees. That's a way you can check to make sure your x is right. When you plug it in here, it should also be 81. Now we need to identify the linear pair, just like we did in the previous example. And I can see that one of the linear pairs exists right here. Right? That would be the 2x plus 5 and the 4y minus 1, or the 81 that we now know it is and the 4y minus 1. Again, side by side on a straight line, 180 degrees on any side of a straight line, those have to add up to 180. So the equation that'll help me find y now would be the 4y minus 1 plus the 81 equals 180. Again, that's you identifying the linear pair. Those angles have to add up to 180. Algebra from there, that negative 1 and 81 combine to give me a positive 80. And I can subtract 80 from both sides here to get 4y equals 100. Divide both sides by 4, and y is 25 in that problem. So x 38, y is 25. All right, our last example looks like the most complex one. We have multiple variables to solve for. In these scenarios, we really just want to break it down, try to find one angle pair at a time, and then go from there. Remember, I think the first thing you should try to identify is vertical angles. I think those are the easiest things to see. What I can see here is segment CF and segment AD intersecting, creating some vertical angles. The easy one to spot is the 20 and the Y are vertical angles. Remember, vertical angles are congruent. So no math involved, just you identifying that y and 20 are vertical allows you to find that y is 20 degrees as well. From here, I know there's another y right here with the 5y plus 10. We'll talk about that in a second. From here though, I'm gonna go to solving for x. And what I wanna find now are those angles that are all on one side of a straight line. If I look at segment DA here, underneath it, I have 3 angles, 2 of which I already know. I have 20, and this is a right angle, 90 degrees here. It might be hard to see on the screen, but there's a box there. There's a right angle there. And then there's x. So all 3 of those are on one side of a straight line. Those must all combine to give me 180 degrees. So there's an equation in there. That x, that's right there, when combined with 20, so adding 20 to it, and combined with the 90, give me that straight line, that straight angle. They have to add up to 180 degrees. And from there, we can solve for x. 20 and 90 combine to give me 110. And when I subtract 110 from both sides, I get my value for x, which is 70 degrees. This brings us now to our z. And we're gonna do the same thing that we did with these 3 angles, just with the angles up top. And remember, now that I know that y is 20, this angle here is 20, I can also find the value of this angle by plugging the y in there to that 5y plus 10. So I'm gonna do this over here. We found out earlier that y was 20. So 5 times 20 plus 10. 5 times 20 is 100. 100 plus 10 gives me 110 degrees. So I know this angle is 110 degrees. I know this y over here is 20 degrees because it was vertical to that. And just like we did down here, I have 3 angles all on one side of a straight line. They have to add up to 180. So again, that key thing, we gotta get straight lines have 180 degrees on either side of them. So up top there, that z plus the 20 plus the 110 have to combine to give me 180 degrees. The 20 and the 110 combine to give me 130. And I can subtract that 130 from both sides and find out that z is 50 degrees in this example. So y is 20, x is 70, z is 50. This wraps up our lesson on 1.6 today. Remember these angle pairs, you have them down: complementary angles, supplementary angles, linear pairs, and vertical angles. You have to be able to identify all of these things. You have to be able to solve for angles and variables using algebra. You have to be able to solve word problems for all of these angle pairs. Again, that's it for today's lesson. I'll see you in the next one, guys. Bye.